Hey everyone, in this video I'll be breaking down the concept of the 4-to-1 multiplexer, or MUX for short. I'll explain how it works, what each part does, and walk you through an example so it all makes sense. What is a multiplexer? A multiplexer is basically a device that takes multiple input signals and selects just one of them to send to the output. It acts like a smart selector or a digital switch. Instead of all the inputs going through at once, it only lets one through at a time based on something called select lines. So, the MUX helps reduce the number of wires or data paths we need, which makes circuits more efficient. Now, this is a 4-to-1 multiplexer diagram. As the name suggests, it has 4 inputs labeled I0 to I3 and just one output. The 2 lines in the middle, labeled S0 and S1, are the select lines. They decide which input is sent to the output. The way this works is through logic gates, which are arranged to make sure that only the selected input gets passed on whilst the others are blocked. Now let's break down how the select lines controls the output. Here's the truth table for the 4-to-1 multiplexer. It shows all the possible combinations of the select lines S1 and S0. If both are 0, meaning 0, 0, then the output will be I0. If it's 0, 1, then the output is I1. If it's 1, 0, then the output is I2. And when both select lines are 1, 1, the output is I3. This means we can control the output just by changing the select lines. Let's see a quick example to make things clearer. Suppose the input values are I0 is 1, I1 is 0, I2 is 0, and I3 is 1. Now let's see what happens when we change the select lines. If S1 and S0 are both 0, then the output is I0, which is 1. If S1 is 0 and S0 is 1, then the output is I1, which is 0. If we set S1 to 1 and S0 to 0, we get I2, which is also 0. And finally, when both are 1, the output becomes I3, which is 1. So depending on the combination of the select lines, a different input is routed to the output. Well, to wrap it all up, a multiplexer helps simplify digital circuits by allowing us to select one input out of many using select lines. In the case of the 4-to-1 MUX, there are 4 inputs and 2 select lines. It is efficient, saves space, and is commonly used in systems where data needs to be switched or controlled, like in processors, memory systems, and communication devices. And only one input is passed through at a time, and the output depends entirely on the combination of the select lines. Thanks for watching.